Hello, everybody. Welcome back to Channel Fan Machinery. The construction of the Esbark Expressway Bridge across the Suyong River marks a significant milestone in regional infrastructure development. Designed to enhance connectivity and reduce congestion, the bridge serves as a vital link for commuters, businesses, and travelers navigating the bustling urban areas on either side of the river. Stretching across the Suyong River, the Esbark Expressway Bridge integrates innovative engineering with modern aesthetics. The structure spans approximately 1.5 kilometers, featuring a sleek, contemporary design that complements the surrounding urban landscape. Engineered with cutting-edge technology, the bridge incorporates advanced seismic protection systems and sustainable materials, ensuring both safety and environmental responsibility. The project began in early 2023, with meticulous planning and collaboration between government authorities, civil engineers, and environmental experts. Construction teams have worked diligently to minimize disruption to local ecosystems and traffic flow during the building process. State-of-the-art techniques, including prefabricated components, have been employed to accelerate construction timelines while maintaining high safety standards. Once completed, the Esbark Expressway Bridge is expected to reduce travel times by up to 30%, alleviating traffic congestion in the Suyong district and surrounding areas. It will also foster economic growth by improving access to key industrial and commercial hubs. The bridge's design includes dedicated pedestrian and cycling lanes, encouraging sustainable urban mobility and promoting a healthier lifestyle for residents. Moreover, its LED lighting system enhances visibility and energy efficiency, contributing to the city's green infrastructure goals. A symbol of progress, the Esbark Expressway Bridge represents a forward-looking approach to infrastructure development, blending functionality, sustainability, and innovation. Upon completion in late 2025, it will stand as a testament to the city's commitment to enhancing connectivity and improving the quality of life for its citizens. The construction of the Barbanya Viaduct is a critical component of the high-speed railway platform between the Ronte and Suksalbo tunnel section. This impressive infrastructure project is designed to facilitate high-speed rail connectivity, improving transport efficiency and regional mobility. The viaduct spans the Barbanya River Valley, an area characterized by challenging terrain that necessitated innovative engineering solutions. Built with advanced construction techniques, the viaduct features precast concrete beams and meticulously engineered foundations to ensure durability and stability. Its design minimizes environmental impact while maintaining structural integrity, an essential factor given the ecological sensitivity of the region. The project enhances connectivity in Galicia, reducing travel times and fostering economic growth by supporting sustainable transport. The viaduct also reflects the integration of modern infrastructure into natural landscapes, balancing aesthetics with functionality. Throughout construction, engineers prioritize safety, precision, and adherence to timelines. Once completed, the Barbanha Viaduct will serve as a vital link within the high-speed network, facilitating faster passenger and freight transport across Spain. This achievement underscores the importance of technological innovation and infrastructure investment in shaping a connected, efficient future. The Mataguero Bridge construction showcases a marvel of modern engineering, with a focus on the meticulous arch lifting process. This intricate animation highlights each step of the operation, offering a glimpse into the precision and expertise behind the project. The process begins with the fabrication of massive steel arch segments, constructed off-site for quality control and efficiency. These segments are carefully transported to the construction site, where they are assembled into position. With the help of specialized cranes and lifting equipment, the pre-assembled arch is methodically raised into place. The animation vividly illustrates the coordination required as the arch is lifted in stages, ensuring safety and balance throughout. As the arch reaches its final elevation, it seamlessly connects to the bridge's foundation, marking a critical milestone in the project. This awe-inspiring sequence underscores the engineering ingenuity and teamwork that makes such feats possible. The Mataguero Bridge stands as a symbol of innovation and connectivity, a testament to the synergy of design, technology, and human effort. Next, construction of Honam High-Speed Railway Section 3-3, Manjong River Bridge PSM method. The Manjong River Bridge, part of the Honam High-Speed Railway Section 3-3, represents a critical infrastructure project designed to enhance rail connectivity and reduce travel time in the region. This construction adopts the precast segmental method PSM, a highly efficient approach that ensures precision, speed, and structural integrity during the bridge building process. The PSM method involves the manufacturing, transporting, and installing of prefabricated bridge components at the construction site. In the case of the Manjong River Bridge, 25-meter box girders, each comprising a single span, are produced off-site at a specialized factory. This prefabrication method allows for strict quality control and minimizes disruptions at the construction site, ensuring adherence to high safety and performance standards. The 25M box girders are fabricated at a controlled production facility, equipped with advanced machinery. Each girder undergoes rigorous engineering design and precision casting to meet structural requirements. Factory-based production ensures uniformity, high durability, and quality assurance while streamlining the overall project timeline. By manufacturing the girders in a dedicated facility, potential delays caused by adverse weather conditions or site-specific constraints are effectively mitigated. Once the box girders are completed, they are carefully transported from the factory to the installation site using specialized heavy-duty vehicles. Transportation planning is critical to prevent structural damage during transit, and specific routes are selected to accommodate the girder dimensions and weight. Safety precautions, including the use of escorts and traffic management, ensure smooth and secure delivery to the Manjong River Bridge construction site. At the installation point, The PSM method leverages specialized equipment to lift, position, and secure the box girders with precision. The prefabricated girders are placed onto pre-constructed piers, ensuring proper alignment and stability. Advanced lifting techniques, such as launching girders using hydraulic cranes or gantry systems, enable seamless installation. By adopting the PSM approach, construction teams can reduce on-site labor intensity and expedite the bridge assembly process without compromising structural quality.